Hello and welcome back to Compiler Programming. Today we're going to continue working on the register allocation, and in particular, before the actual allocation, we need to learn how to save the registers and restore them for non-volatile registers. So here I have MSDN article about function Prolog and epilog, and it shows us how to do that. So basically, right now we only have this line, which is sub RSP fixed size allocation for allocating some size on the stack. And we're gonna add these pushes for the registers. An important thing, I think, is that in epilog code, they need to go in the opposite order. Otherwise, things will not work out as they should. So let's get into that. We have, I guess it is inside of function.c, we would have function encode, right? And here we will need to do some extra work. Okay, stack allocation. So here we'll push non-volatile registers. Actually, probably better to, I don't know if I should extract it in a separate function or not. Let's keep it as is for now, I guess. Push non-volatile registers. Okay, and then here we say in reverse order. And here we will need to pop them, I guess. That happens before RSP is restored, right? Yes. No, this is Prolog, epilog. No, first RSP is restored and then they are restored. That's okay. Yeah, actually makes sense. So this goes first. And here we say pop. Okay. Now I just need to remember where was the code that we dealt with the calling. I think it was here in call. Maybe it was here actually. Call something. Overload maybe. So it is actually here. Yeah, call function overload. And this is where we were doing the saving and storing of volatile registers. So similar thing now will have to happen in the encoder. Okay, let's take that and go back to our function encode. And let's see how it goes. So set, we need to go in opposite direction. So we start with here and we say, that's actually a bit awkward with the fact that I think register is an unsigned number. Or no, this is an enum, so it should be fine to do it this way. More than equal R0 minus minus register index. Okay, we don't need anything. Actually, no, we do. So value to save actually is something we do want to have. Maybe we just need an operand though, because these are just registers. There is nothing particularly fancy about them. So we can say operand to save is this. So if this is not a volatile and it is occupied, then we would need to save it. And the way we are saving it is we need to do a push instruction. Which we don't have at the moment, I think. We say push, and then it accepts only one argument, which is now to save. Register R0 isn't declared, where it's REX. Register A, I guess. Okay. And push is undeclared identifier. Okay, that is fine. We can go into instructions and just add push and pop. For that, we will need information. Now it's going to be very bright on the screen, so sorry about that. Push. And right now we are basically interested in pushing registers, so this form of the instruction. So let's do that. We have push. It's 50, 50, 50. It accepts a register. And as far as encoding, it's called plus R. So basically we are taking this opcode and adding the number of the register. Okay, let's try to run the tests. Ideally, nothing should actually happen. Yep. And I think even if we look at the assembly, we will not see anything because we don't mark any non-volatile registers as occupied right now. So I think we will see basically nothing, no pushes in the code, but it doesn't hurt to verify. So let's do that. Go here, we go call. Yeah, and as you can see, there are no pushes right now because we don't mark any registers as occupied, which is what will happen when we actually have a register location. It will take some register and say, okay, now that register is actually occupied. It might be that we will have to also track whether the register at any point was occupied, because we can sort of release them and like track separately if we which registers were ever pushed. Yeah, actually that might be a better option. For now, let's finish with encoding. I will just try to manually mark something as occupied, and then we will see the encoding working, and then I will go and change how this is done. Okay, so we have push and we have pop. Actually, we need to, it probably makes sense to include these ones as well and write a comment. And the comment is that these encodings must go first because it is the expected form for register saving in Prolog. So basically I think we expected that this is exactly how we encode this, I think. But I rather not risk it and say this is epilog. Okay, and the other one is ff/6. So this is easy. Six, six, six. RM, RM, and RM. And I did it other way around, of course. I think in general, yeah, let's not write this, but in general, we need to always make sure that the R versions are the first ones in the encoding because they are just better. They are shorter and stuff. And right now we are not doing instruction selection in the sense of like which instruction would be the shortest. It's sort of implied, but this will be important eventually. Okay, so ff/, okay, that's fine. Let's go to pop. And here it's basically the same, but with 58. And it's even the same here, except the opcode is 0. And here it's 888. Yep. That sounds good. Let's go back to our function stuff. And we need to pop them back. Here again we are doing it in the right order, so they are sort of opposite, they're kind of nested within each other. R15, we have register, yeah, that's the same thing, and we say saved. Again, these loops are going to change a bit in a second because, as I mentioned, we can like reserve a register but then release it, and we still need to track it for pushing and popping purposes for the function. So function will have to have its own tracking array, I guess, for the registers that were dirty at any point in time. Okay, we build, we check again, there is nothing happening. Yep, we don't see any pushes and pops, that's fine. So now I will do something like fix me, check in, and we will mark one of them as occupied. So register bit set set. Here I will say, I don't know, R13, probably a non-volatile register. And yeah, that's fine. Function use60 what? Let's just put the full operand here. Just to be sure. Yeah. This is what it was complaining about. Do we have R13? Okay. Good. And now let's try to run tests again and see. I expect that unbinding test will either crash or not work. I guess because we are not actually doing anything with those registers and we're crashing anyway afterwards, then it doesn't matter. But unbinding right now doesn't actually work, and we will need to look at that in a second, and I'll explain why. Let's check though if we did generate any pushes and pop instructions. Okay, so we have push R13 and we have pop R13. Great. So that part works. At least our encoding seems to be correct. That's always great to know. Let's make this one a bit smaller so we can see more of the assembly. Okay, so that was the first pass of this, and now I'm actually gonna change how it works. So I'll go to value and we go to function builder. So this goes into code block, and I think this is good that it's actually there. But as far as non-volatile register go, they should be separate. And they only matter to the function. So whether something is occupied or not is a matter of each code block, right? Because if we go out of scope, we will say, oh, actually this is no longer occupied, and it's fine. But if something was at some point occupied, we need to track it for saving, and this is why this will be here. So we'll say array, I guess S32, or maybe I should put operands here directly. I mean, it can only be registers really, so array S32 is probably fine. Saved, or maybe like this, used non-volatile registers. Okay, we have function begin, where we will need to now initialize this thing. So we'll say that what's it called? Use non-volatile registers, right? Is dynamic array make array as 32, and it doesn't really matter. Technically, this thing can be also a bit set, so maybe it should be. Let's make it a bit set. So U64, use non-volatile register bit set. Then we don't really need to initialize it, it will be automatically 0. And we don't really need to say whether they are volatile or non-volatile. we will just have used register bitsef. So whenever we are allocating a register or adding or using it for, actually for arguments, it doesn't matter because they are considered volatile. So yeah, whenever we are allocating a register, we will just mark it in this bit set and say, oh, actually, this was used at some point. And this is what we will use in the function in code to check if we need to. So here like this, and here, instead of checking it, so if it is used and it is not volatile, so basically these two things sort of need to be other way around. Yeah, so if it is used and it is not volatile, then we are pushing it. That seems reasonable. Apparently doesn't seem reasonable to the compiler. So what's going on? Access violation during execution. Great. Why exactly? I expect builder bit this to be 0. So it is 0. Yeah, I guess I know what the problem is. So because now we are going through two different arrays at the start and at the end. Hopefully that helps. Yeah, so we just had misaligned stack after, because it was mismatched. Okay, so that sounds good to me. However, so that was the easy part of this stuff. The hard part comes with stack unwinding, because when we add this stuff into here, we also need to add it to the unwind codes. So let's go there and look at that. And the main problem here is actually not adding them to unwind codes. That's pretty straightforward. And the problem is we don't really know the size of the, like we again get into this situation of if I don't want to copy memory around, I will need to do some weird things with trying to estimate the sizes of all the structs. And I think for now I'll just gonna ignore it. So I will do what I did here, and I will do something very nasty. I will say and bind info max count of codes for non-volatile register push, and here I would basically say 16, I think. Yeah, so push non-volatile just takes up one node, and that means that we can just do it this way. This is very like, it's pretty ugly, hacky, and whatever. There is already fix me here that says that we shouldn't be really doing anything, something like that. So I will definitely take care of it at some point, but I haven't decided yet what is the best way to go about it. One way would be to just basically say, okay, we're gonna copy memory, and we will allocate as we go, and then do the necessary adjustment. Another way is to keep it basically sort of the same way, where we estimate that, okay, it's going to be no bigger than that, and if we ever get a bigger result when we crash, and this is a bug in the compiler, but that means that inside of the executable and inside of JIT code we have more memory usage than necessary. So there are problems with this stuff. Anyhow, first of all, let's check that this doesn't crash, where I just got a bit more memory. Okay, that seems to be fine. And now we are ready to also push this to here. So this is going to be just the same loop. We have, that's actually an interesting question. Does stack reservation, they go in the same order, I guess, as they do inside of here, right? So we first push the registers and then we do sub. So I imagine that this needs to go in the same order. For that we will need U64, or maybe, what is the type of count of codes? It's actually U8. Okay, so let it be U8. Count of code, or unwind code index is 0, and we do it like this. So yeah, first let's make it a bit more dynamic and make sure that doesn't crash, and then we will continue. Actually, no, that's plus plus. Plus plus. Plus plus. And now here, we just will do it this way. So technically that should be exactly the same as it was before. Okay, and our unwinding works. That's good. But now we don't have hard-coded 0 and 1 here, because the allocation should go after them, I imagine, at least. Let's do this. And yeah, we go in opposite order. We will not need an operand here. instead we will say that unwind info, yep, it's fine. You will push non-vol, and we'll need to figure out what to do put here. Epilogs must appear first in the prolog and okay, that's fine. Are you gonna tell me where to put the fields though? That would be neat. That's not cool. Push non-volatile integer register. Okay, so let's read this section carefully. Require an assigned offset to a value in the local stack frame. This offset is from the star, that is the lowest address of the fixed stack allocation. If the frame register field in the unwind equals 0, this offset is from rs p. For all of codes, the offset is always multiple of 8. This is not very well described, I have to say. Okay, so maybe we can look at this stuff. Push reg. Can I find this file? Okay. There is no push reg here. No, it doesn't seem to be defined in that place. Push reg. Okay. Let's try to look at the definition of unwind code and see what we need to put in there. So I guess unwind op is we have op info. I imagine that's a register index that we need to save. Those are pretty straightforward. And code offset is then this divided by 8 offset from the lowest address of this thing. It's always a bit hard for me to wrap my head around this stack and in which direction it needs to go and where addresses need to be, but let's try to figure this out. But actually they say separation info is the number of the register. Yeah, so let's put that in. Let's put operation info to be register index. That's fine. And code offset is, I really wonder if it is offset in Prolog or not. Certain operation codes require an unsigned offset to a value in the local stack frame. This is an offset from RSP. I still don't know if they want me to put, like, what they want me to put in here. Do they want to put the offset in the, let's actually check. Okay, so here they explicitly say that this is an offset in Prolog. Okay, so that's fine. We can do that. For these things, the offset in Prolog, I guess, is this is a bit awkward. I probably want an array here as well to get track of it easily. But for now, let's just put something in. So stack allocation set in Prolog. We have offset of the start of Prolog, right? Where is it? It's conveyed. Wait, how do we calculate stack allocation offset in Prolog? Code base ORV plus buffer occupied minus function start. Okay. Yeah, this is kind of yuck. Okay, we're gonna make a new type struct function pushed register. And here we will have U8 register index, and we would also have I guess U8 offset in Prolog. Although now that I'm thinking about it, it probably makes sense to just create these unbind codes right away and just write them out if we are doing that anyway. That's an interesting question. Let's go for that. We have unwind code. We do type def dynamic array type of unwind code array unwind code. This is going to be a bit inefficient, but it's going to be fine for now. So what we will do is we'll say array unwind code. Unwind code is dynamic array make of array unwind code. And let's not forget to get rid of it afterwards. Yeah, this thing needs an operand after all. Well, let's create one. It's fine. That also is another reason for us to be doing it a different way, so we don't have to create all these temporary things in here. Okay. So we created this array, and besides encoding the instruction, we also will do dynamic array push. Unwind codes. Unwind code. And whatever I was trying to do here. For U64 is 0. I is less than dynamic array length of unwind codes plus I. So here we just will copy it. So we'll say dynamic array get of unwind codes I. Okay, that's fine. And here, let's restore it to how it was. So this is gonna be reg index uvop push nonvol and code offset. So this is something that we will need to change into a macro, I guess. So let's do that. Define function prolog function offset in Prolog, and that is gonna be this stuff. And actually this needs to be to U8. Yeah, this is gonna be better. And I think I will also push this directly here and just copy it out. So I will probably take out this part and put it into here later, but this is not for now. Stack allocation Prolog isn't defined. Yep, that's fine. We'll do it this way, and we can undefine it here so it doesn't leak to other places. Okay, you know, the lack of local functions is one of the big things that is pretty annoying about C. But that's why we are doing this language, so it's fine. I can survive for now. Okay, so we pushed the instruction, we pushed the code. We will copy these codes into here. And then we will go with the regular codes. First, I will undo this stuff. And let's check that we are still alive and well. Now I will, I guess, comment out this stuff and try to use here the same array. So this will be like this. But it needs to be in opposite direction. So dynamic array length of unwind codes -1. I is more equal to 0 and minus I. And we will need this stuff here, I guess. And instead of red index, we will just say unwind codes I. And this is operation info, right? That's how it's called op info. Okay. That looks good. And we just encode the pop. Okay. Let's see like this, where we actually do push and pop. That looks good. Let's check in the assembly before we move on. Okay, push R13, pop R13. Fine. Let's actually check that we are doing it in the right order. So we also will put R14 in there. And we have a issue. Okay, what is the issue? So pushes and pops seem fine, but it broke our unwinding. Well, I guess because stack is... yeah, no, stack is completely messed up. Okay. Yeah, then it makes sense. So we need to actually put them here and hope that it fixes the issue. Let's try. And it does. Okay, so that's perfect, I guess. Then everything works as expected. That's nice. Yeah, so as you can see, now we can push registers. They are pushed in opposite order for indexes, the same thing as it says in here. I don't actually know if it is required that we start with the highest number registered and go to lowest. I think this is just sort of a consequence of how they are doing it. I think the important part is only that here you do the opposite order of whatever is happening here. At least that's my understanding of this stuff, but I might be wrong, and there is actually some extra magic that requires that the higher registers are up, but this is how we're doing anyway, so it's fine. Yeah, so that's very, very nice. We have working, pushing, and popping, and that means that we are actually ready next time to start doing this for real and get register allocation on the road. But for today, that's all. Thank you very much for watching, and hopefully see you next time.